We're continuing our notes, and this is for database management systems. There's more, and this is in the playlist link below the like button, but this specific section is commutative and associative. So we have union and intersection, and they're both commutative operations. These are both commutative, and remember, they look like this. We've gone over these previously. Union and intersections are also associative operations. So we can combine them just like this. Basically where we have two in here, and then we have one on the outside, and then we have a union between them. And the same thing for our intersections. Now remember, the minus operation is not commutative. So that's just something to note right here. That's just a little kind of recap right here. The previous notes can be found in the description below the like button, the videos on them are in the playlist link below the like button. Here we're going to be looking at Cartesian products. So Cartesian products are basically how to make tuples of two different things combine. So like, let's say we have two elements R and S. They're both like two separate tables, like how we have here. In this example, we have R, we have A, B, C. In S, element S, we have D and E. So we want to combine these two together. So we do R times, or XS, and this is being sent to our Q. And it's going to look like this. Our R comes first, so we're going to have 1, 2, 3. And notice how we keep going on. We have 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6. Twice, right? So 4 times each. And the reason why it's 4 times each is because look at our SDE. We have 4 tuples here. So for every one of these tuples, we need to have a 1, 2, 3 and a 4, 5, 6. If we look at this first line, we have 1, 2, 3 and then 7, 8. So that takes care of this first line. And then we're also going to have a 1, 2, 3 for our 9, 10, a 1, 2, 3 for our 11, 12, and then 1, 2, 3 for our 13, 14. Now, we also have to associate our 4, 5, 6 with this. So then we have 4, 5, 6, 7, 8, 4, 5, 6, 9, 10, and so on and so forth. So basically, we're kind of you can think about factoring it in to the S, kind of multiplying it together, and that's going to give us all our outcomes right there. So our Q is going to be the combination of all of these. We're sending this to here, so Q is going to be sent, and this is just noting that our Q is going to have all of these. We're sending our R with all of our A attributes times our S with all of our B attributes. And this is going to be the size of M plus N attributes. If R has N R tuples, this is denoted as an absolute value of R, because we don't want any negatives here for just a size, is equal to NR, and S has NS tuples, then our Q is going to be NR times NS tuples. So that's just the tupling size. So that's how we would look at that. We have another example here. This one's a little bigger. We want to retrieve a list of names, each female employee's dependents, so the employee's first name, last name, and dependent's name. We're going to be using this. We've referenced this a lot in previous videos, linked below the like button in the description, but we're going to be doing a separate example here. This one is a lot more complex than the other ones previously. So we want to retrieve a list of names with each female employee's dependents. So let's start off with retrieving a list of names of the female employees. So we want the column from our list. In this column, we're going to look at the sex, because the sex holds if it's a male or female. We want to return F for female. And then we have our entity, which is employee. So with this here, we are going to send it to our female employees, and that is going to hold this information here. Notice how we have all female inside of here. Now, we want to get the employee names, so we're going to pass the employee names into here, because we want to retrieve a list of names for each female employee's dependents. So our list of names inside of emp names should be right here, where we just get their name, last name, and social security number. We need their first name and last name because it asks for the name, and we need the social security number because it's a key, so we can identify them. That way we can identify the dependents and such like that. So we can omit all this other information since we don't need it, and that's why we did it in separate parts. We'll explain that more right here. So that's stored in our emp names. We have this right here. Now we're going to store into our emp dependents the employee names times the dependents. So inside of our emp dependents, it's going to be this entire long list right here. We have all of our possible dependents, and so we have all of our names, these 3, and then we have all of our dependents' names. So we have like 7 tuples and we have 3 here, so we should have like 21, I believe, different possibilities. And that's just see how we have all of these Alicia, these Jennifer, and these Joyce. We're assigning them all to the Alice, Theodore, Joy, Amber, Michael, Alice, and Elizabeth inside of here. So those are going to be assigned. This question is asking us to retrieve a list of names, each female employee's dependents, and so our employee's first name, last name, and dependent's name. To know this, we need our dependent's ESSN, because it associates with the SSN right here. So we need to check to make sure the ESSN is the same as our SSN, because the ESSN is a foreign key. So if we come down here, we want to check them. This is going to be our filtering. So if we compare all of these, we're going to only see that Jennifer Wallace with our Abner is the same. So if we just skip through all of this, we have our Jennifer Wallace and we have Abner right here. We can see that the SSN and ESSN are the same. So our SSN and the employee SSN, the one that it's based off of, since they're equal, we're going to put it inside of here. And that's what we would have right here. So now we just want our result. And remember, the result is just asking us for the first, last name, and dependent's name. So we need to take this information and put it into a smaller table. And that is how we would look at and do our Cartesian products. That's all for our examples and the material that we've gone over.